Hello, family. This is Just Dave, the informed patient. Excuse the cane. I'm in a lot of pain today, but this lesson's been so delayed, I had to give it. This is lesson number 5. I put S because it is sickle cell lesson. Everybody wants to learn more about sickle cell and dialysis too. We'll do both. This is kind of a 2-for-1 you get. We're going to start off with basic definition. Sickle cell disease. One second. Sickle cell disease. Sickle cell disease is a group of hereditary red blood cell disorders. This is the 2-for-1. Number 1 is sickle cell disease. It is a group of hereditary red blood cell disorders. So there's a couple of them. There's sickle cell SS, sickle cell SC, sickle cell beta thal, so many other genomes, if that's the correct word, of sickle cell. There's so many different types, I should say. I don't know them all. They're always, I'm not going to say changing, but there's always new types of sickle cell disease found. Each region of the world kind of has its own kind of morph. It kind of morphs around a little bit. We're kind of seeing, scientists, not myself, but it is a group of red blood cell disorders, and it is a group of red blood cell disorders that affect hemoglobin, HGB. Hemoglobin is the protein that carries oxygen in your blood. So you got your blood cell, and then you got hemoglobin that carries the oxygen. That's how oxygen is moved through your blood. That's how that little thing works that they put on your finger, the little red light, your finger, your ear, wherever, your toe. That measures the amount of oxygen in capillary blood. That's how you get, like anything they usually say under, some places a 94, some places a 90, that they'll give you oxygen, or they'll say you're oxygen deprived. It depends on, people kind of debate that when you need oxygen. But all in all, it is a sickle cell. Sickle cell is a group of hereditary red blood cell disorders that affect hemoglobin, the protein that binds to oxygen. So sickle cell is a group of disorders that affect the red blood cells, and hemoglobin is what it affects. Hemoglobin is the protein that carries oxygen. So with sickle cell, our cells are deprived of that binding protein, that oxygen. It's not there. So it causes the cell to kind of look like this. This is a normal red blood cell. You see the blue? The blue is the oxygen, full of oxygen, flowing through the body, flowing through the vessels nicely. And then you got sickle cells. There's no oxygen. There's no blue in here with the sickle cells. Then you got these crescent shaped, moon shaped, elongated, sticky. They stick to each other. They bind like that. Now, this is let's just call it a vessel or vein. Hope you can see that. Here we have the blue. We have oxygenated blood just flowing beautifully. These kind of cells flowing beautifully. But then up here we have a blood clot filled with these type of cells. These cells have been the oxygen deprived cells are all in here making a clot because they're smaller. They're not smaller, they're longer, they're stickier. They're shaped like this. Imagine pushing this through a straw versus that. It's much easier to push that through a straw than that shape. And if we have enough of these cells, you have what you call as a sickle cell crisis, what I'm going through now. Pain in a certain area of the body. Significant pain because of this clot. We don't know where that clot is, we just know that area hurts. Because when that area is starved of oxygen, the white part, it's starved of oxygen, you have bone death. If it doesn't get oxygen, you don't get oxygen, what happens? You die. So imagine inside, the vessel's not delivering oxygen to whatever that organ is. If it's my hips, it's called the vascular necrosis. The bones start to die. You need a hip replacement. If it's the brain, the brain is starved. You could have a stroke. If it's in younger sickle cell disease patients, they get hand and foot syndrome where their fingers and toes will swell significantly, very painful. I remember it as a kid, and even still, they call it kid syndrome, hand and foot syndrome. But I also get it as an adult too, not as bad, and I can deal with it. But my joints will swell during the winter time, the colder months. So whatever it's starving, it's going to do damage. If it's an organ, it does damage. Let's say these are the vessels going to my kidneys. Damage. Done. Kidneys are, they're being shut off. Even if it's for a little while. You just think about it. Your brain starved of oxygen for 4 minutes and you start to, degrade. You start to lose, life function basically. Brain cells start to die after just 4 minutes of no oxygen to the brain. So imagine days of no oxygen to an organ, a leg, a bone. It's causing damage over time. And then, as you're young, what I notice, you can replace and build things up. But as you get older, that damage becomes like permanent, especially time after time. You have a crisis, you have so many chest crises, and, I don't know what you would call it, but each crisis does damage over time to that specific area. Just because you're a kid and you're like, oh, he had a leg crisis, he couldn't walk for a while, but now he's good. There was a little bit of damage done there. I don't know what the percentage you want to put on it, but depending on how long, because that area was starved of oxygen, so there can be a little bit of necrotic bone death. Wherever there's no oxygen, there's death. We are mammals. So this clot is basically what a sickle cell crisis. Hey, you're getting 3 in 1. A sickle cell crisis is. Once we have this clot, crisis is defined by pain, fever, a lot of things it could be. It presents different, in each patient. But again, we have the regular sickle cell with full of hemoglobin, a sickle cell with no hemoglobin. We have the healthy oxygenated cells flowing, and then we have the sickle cells flowing, and they form a clot, squeezing on those vessels, causing vasoconstriction. Dilation is when the vessels go bigger. Dilate, just think. Constrict, squeeze like a snake, a constrictor, making it smaller. So when that happens, the clot can even get worse. I don't know if they still do it, but I know in the old school, they would actually drain blood from certain areas. I've had nieces that have had that done. Thank God I have never. Usually if you get priapism, there's a pretty harsh treatment. Priapism is a prolonged erection, but in sickle cell, if it lasts more than an hour, it's dangerous. And some people can have it last for, several hours, days. So you're sitting there with an erection. They're going to drain blood out of it. They're going to give you steroids and shots in your testicles and in the main vein and all that. So you can just imagine kids going through this. Thank God I only had priapism once in my life, and it only lasted for a little over an hour. That's like the one thing I can say that I have not had with sickle cell. But it's extremely painful, very painful. I don't wish that on anyone. But again, last time, lesson number 5S. Sickle cell disease is a group of hereditary red blood cell disorders that affect the hemoglobin, the protein that carries oxygen. So think of sickle cell, regular cells, full of oxygen, sickle cells, crescent, no oxygen, causing clots, causing death, pain to tissue, bones, whatever it's the clot is. Thank you. I'll do an update about how my health is right now, because my brain is okay, my mind is fine, but I'm in a lot of pain, sternum and whatnot. But I'll talk about that in another video. I don't want to make videos too long. Thank you. Have a blessed day. This is the Informed Patient, lesson number 5. Ciao.